This is the presentation that corresponds to projects 1 and 2 for EML 4806, Modeling and Control of Robots. We were group number 13. My name is David Neer. The projects that we were working on were the analysis and synthesis of 4-bar and slider crank mechanisms. These mechanisms hold many applications in engineering usage. Some of them are pumps and compressors, windshield wipers, and then something as seemingly simple as folding chairs. In general, these mechanisms are in part categorized by their mobility, which for the slider crank and the 4-bar mechanism is equal to 1. This is also known as 1 degree of freedom mechanisms, which implies that only one input is needed in order to define the motion of the rest of the mechanism. The study of the geometry of this motion is done through kinematic analysis, and then the synthesis part of the project refers to the design of the mechanisms. And when the two of these processes are put together, it helps to ensure the fluidity of motion of the mechanism as a whole. The analysis is going to be shown through the rest of this presentation and through the project as graphs that are going to represent trajectories of paths, and also through graphs that show joint and acceleration of joint velocities, and accelerations with respect to the input. Next, Yoelmir is going to present.
Hi, my name is Yoelmir. I'm going to be talking about the position analysis for the 4-bar mechanisms. First, the 4-bar mechanisms, like you mentioned, is 4 bars attached by 4 points. They are described basically by the length of the links and the angles of the links with respect to either each other or respect to an x-axis. So therefore, we were given a system which is measurement. We were given R1, R2, R3, and R4. We were also given the values of theta 1. And we were told theta 4 will be the input. As a result, we will have to find out which are the theta 2 values and theta 3 values for different theta 4 values. We were told to analyze them throughout a motion every 1 degree throughout the whole 360 degrees motion of the theta 4. First of all, you have to decide which classify your system. There's 2 types of system, which are classified using the Graf's rule. Our particular system was described as a type 1 mechanism, which is basically a crank rocker mechanism, which one of the links goes 360 degree rotation, the other one goes back and forth. When you have that described, in order to describe any mechanism, whether it's type 1 or type 2, you have to describe it like I mentioned through the thetas on the arc length. But since we have 2 outputs, we need 2 equations to find them. The 2 equations we have are these 2 equations, which are based on, one is based on sine of the angles, the other one is based on the cosine of the angles. In order to find theta 2s and theta 3, in our case, basically you have to add those 2 equations, and through some mathematical manipulations, we cancel theta 3 in our case. We're left with the function which is theta 2 function of the rest of R3, R1, R4, the rest of the known variables. And then when we have theta 4, evaluate theta 4, we're gonna use all the known variables to then go back to one of these equations and find theta 3. If you desire to know the velocity or the acceleration, you could differentiate these 2 equations by ddt, depends on the variable. Here we're showing you a model of the system, or our particular system, in SolidWorks compared to the values out of Excel, out of our Excel sheet. As you can see, a simple process that could be done and analyzed with an expensive product could be easily done using these formulas through Excel sheet. Next, turn the same correspondence. Here, we could also put a plot of theta 4s versus the theta 3s in this case. You could put theta 2 too. Also, this will let you know the range of which the mechanism works. For example, here we see the mechanism works in this range and in this range. However, this too is nothing more than a mirror image of this same mechanism. This will be this mechanism about R1, so it will be upside down. This mechanism upside down. The zeros in the middle are places where theta 4s are not defined, like it cannot go there. Basically, the two functions here are basically an example. Theta 4 are the same values here. However, theta 3s have the same values here. Therefore, every time you calculate for theta 2, you will get two theta 2s and two theta 3s respectively, out of which we had to choose one. And that pretty much concludes the four-bar mechanisms. Now, we'll show you the slide rank. Thanks.
Hello, my name is Dariesky, and I'll be presenting the slider crank. This is the information that we got to make our slider crank mechanism. Using that information, we found A nut and B nut in order to find the pole positions for the slider crank. After we found the pole positions, we found C1, C2, and C3, which are points located on the line of slide. And this is the synthesized mechanism with the changes that we had to make in order to make the system work. This is a graph showing the 3 points of the C1, C2, and C3, which make a straight line, which is the slider trajectory. And this would be a sample of the slider crank, which is not our slider crank, it's just a sample of a slider crank system. And this concludes our presentation. Thank you.
So I mean,